Hi, my name is Muhammad Azim Daniel Manorizan. My register number is 01DKA20F2050. And our group will present about direct shear test. And our group, the Putri Nabila binti Maizer 01DKA20F2049. And Muhammad Fikri Iqbal bin Abdul Rahim 01DKA20F2051. And last, Muhammad Firdaus bin Muhammad Rosli 01DKA20F2052.
Hello, my name is Muhammad Fikri Ibrahim, 01DKA20F2051. Introduction. The test is carried out the attack disturbed sample or remodeled sample to facilitate remote proposal. A source sample may be compared at the optimal moisture content in a inspection mount. The specimen for the direct shear test shall be obtained using the correct alter provide. Alternative, sand sample can be placed in a dry state at a record density in the assembled shear box. A normal load is applied the specimen and the specimen is a shear rate across the predetermined horizontal plane between the two halves of the shear box. Measurement of shear load and shear displacement and normal displacement are recorded. The test is repeated few two or more identical specimens under different normal load. From the result, the shear strength parameter can be determined.
For objective, to determine the parameter of shear strength of soil, comprehension, C and angle of fraction.
Okay, next the apparatus. First is direct shear box apparatus. The second is loading frame. Third is dial gauges. Next is probing ring, temper, straight edge, balance to weight up to 200 mg. Next is aluminium container, and lastly is spatula. Procedure. First, weigh the interior mass of soil in the pan. Second, measure the diameter and height of the shear box. Compute 15% of the diameter in milliliter. Third, carefully assemble the shear box and place it in direct shear device. Then place a porous stone and a filter paper in the shear box. Fourth, place the sand into the shear box and level off the top. Place a filter paper, a porous stone, and a top plate with ball on top of the sand. 5. Remove the large alignment screw from the shear box. Open the gap between the shear box half to approximately 0.025 in using the gap screw, and then back up the gap screw. 6. Weigh the pan of soil again and compute the mass of soil used. 7. Complete the assembly of direct shear device and initialize the three gauges: horizontal displacement gauge, vertical displacement gauge, and shear load gauge to 0. 8. Set the vertical loads or pressure to a predetermined value and then close breather valve and apply the load to the soil specimen by raising the toggle switch. 9. Start the motor with select speed so that the rate of shearing is at a select constant rate. And take the horizontal displacement gauge, vertical displacement gauge, and shear load gauge reading. Record the reading on the data sheet. 10. Continue taking reading until the horizontal shear load peak and then fall, or the horizontal displacement reach 50% of the diameter. Okay, this one is data. Shear box inside diameter 6.2 cm, area 31.17 cm for equal 4.83 inches square. Shear box height 4.9 cm, soil volume 119.9 cm, interior mass of soil and pan
1000, final mass of soil and pen 720.82 cm, mass of soil 2779.18 gram, density of soil 1.665 gram. Now I have a 3 schedule. First, displacement rate A and displacement rate B. Displacement rate A, normal stress 2.27 psi. Okay, and normal stress displacement rate B 4.55 psi. And displacement rate C, normal stress 6.82 psi. Okay, this one is for graph for direct shear stress. This green normal stress 2.27 psi, purple normal stress 4.55 psi, orange normal stress equals 6.82 psi. Analysis. First, calculate the density of the soil sample from the mass of soils and volume of the shear box. Second, convert the die reading to the appropriate length and load unit and enter the value on the data sheet in the correct location. Compute the sample area A and the vertical normal stress SV. SV per equal N and A, where N normal vertical force and SV normal vertical stress. 3. Calculate shear stress using T, where F H equals shear stress measured with the shear log gauge. 4. Plot the horizontal shear stress versus horizontal lateral displacement. 5. Calculate the maximum shear stress for each test. Conclusion. Direct shear test is useful when cohesion-less soils are to be tested. In this test, the value plane is forced to occur at a predetermined location where both normal and shear stress are acting. The sample is placed in a closed shear box, fixed at the base with the top free to translate under a horizontal force. The direct shear test can be used to measure the effective stress parameters of any types of soils as long as the pore pressure induced by normal force and the shear force can dissipate with time. The experiment, we use the clean sands as sample, so there is no problem as the pore pressure dissipates readily. However, in case of highly plastic clays, it is merely necessary to have a suitable strain rate so that the pore pressure can dissipate with time.